Welcome back to the channel. Boiler water level control system. Maintaining the correct water level in the boiler drum is paramount for safety and steam quality. Too high a level causes carryover of water droplets into the steam lines, potentially damaging sensitive equipment like turbines. Too low a level exposes the furnace tubes, which can lead to overheating and catastrophic failure. The consequences of improper water level control are severe, necessitating robust and reliable automation. The most advanced and common system used on marine boilers is the three-element control system. This system is necessary because a simple control method cannot account for a deceptive phenomenon called swell and shrink. Let me explain. When steam demand suddenly increases, the pressure inside the boiler drum drops slightly. This pressure drop causes the existing steam bubbles in the water to rapidly expand, making the water level momentarily swell or rise significantly in the sight glass. A simple control system, seeing the rising level, would mistakenly reduce feedwater flow. However, water is actually being lost as steam. Conversely, a sudden drop in steam demand causes the water level to shrink. The three-element system overcomes this by incorporating three key measurements, or elements, to accurately reflect the true condition: drum water level, steam flow, and feedwater flow. The primary signal comes from the drum water level sensor. This is the main measurement that dictates the final set point. The secondary, crucial signal is the steam flow measurement. When the boiler's steam flow suddenly increases, the system anticipates the need for more water and immediately opens the feedwater valve slightly. This feed-forward action compensates for the swell effect instantly, ensuring the valve opens before the level measurement has even had a chance to react and distort due to pressure changes. The third element is the feedwater flow measurement. This acts as a feedback loop, confirming that the requested amount of water is actually flowing into the drum. It ensures the flow matches the required rate, compensating for any pressure variations in the feedwater line that might affect flow. The three signals are fed into a three-element controller, which calculates the precise required opening of the feedwater control valve. This sophisticated combination ensures that the feedwater flow exactly matches the steam flow leaving the boiler, maintaining a stable level within strict safety limits, regardless of sudden changes in engine load. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.